Now on this question, they don't give you the equation, they want you to find it, then they want you to graph it, find the center, and all the other information listed here. What you should do though is see what they did give you. This is a case where it would be good to draw a picture. So let's go ahead and get the rectangular coordinate plane here. We can start with the focus. So that would be here. Let's say this is 0, -4. And then the vertices go further. They give you both vertices here. One's at -8. So that would be just about here. And the other one would be up here. The focus and the vertices, they'll be going in the same direction, meaning that they'll both be vertical or they'll both be horizontal. So because these are both vertical, like both sets of information are vertical, then we have the kind of ellipse where it goes up, down like that. And you could even sketch it. You could fill this out and say that it would be something like this. But we don't know the side or the 2 points on the minor axis just yet. We can find those, but for now, we'll leave it like this. We were able to plot this. We know it's the one that goes up, down. This would be the vertex that goes up in the positive direction. This would be positive A. This one would be negative A. This one went down, so this would be the negative C. If this is -4, then it would make sense if this one was positive 4. See, they go the same distance in both directions. So that's how you can tell.
Would the center stay at 0?
It's exactly what you're thinking. The center is going to be 0, 0 because it didn't go left or right, and it went the same distance up and down, which we can see from the 8 and the -8. So that means that we know the center is 0, 0. We can just label that there. We also have to find the equation. So we found the center already. We also know the vertices. They gave us those. And now for the equation. To find the equation, what you want to think about is that it's going to be based off of this, where you have x minus h squared over b squared and y minus k squared over a squared, and that equals 1. The important thing about the ellipse is that the bigger number, or let's say it this way, the a squared, which will be the bigger number, it has to go under y, because it's this kind that goes up, down. It's a vertical one. So that's why I put the a squared under the y term and the b squared under the x term. We can also put some other information here to it. See, we can find out what a is. A was the distance going up and down for the two vertices. So that would be the plus or minus 8. If you square these on both sides, this turns into a squared and this would just turn into 64. At the same time, we can do this for C. I can go ahead and put a plus or minus 4, but if we only use the information that we were given, the -4, you would still get the same answer. This would still turn into a 16, whether it's plus or minus or just the minus. We also know that the center, which is HK, this is 0, 0. So we can update this equation a bit. We know everything except b squared. But let's go ahead and find b squared. The important thing to remember with the ellipse is that it has a special equation. It's a squared minus b squared. That equals c squared. And so we know that this one is 64. We're looking for b squared. And this one's 16. We'll move the 64. And when you do that, this turns into negative b squared equals negative 48. And then go ahead and divide both sides by negative 1. And you got b squared equals 48. Continue this over here where there's some more space. Here you want to find out what the square root of 48 is. You want to get it as a simplified radical. And there are different ways to do it. What you want to think about is what's the highest number that's a perfect square that can go into these. And you can make a list of perfect squares. You can start with 2 squared, 3 squared, 4 squared. This would be the process. If you see it right away, you can always just go ahead and start it right away. But if you notice, when you get to 7 squared, we pass the number itself. So that's definitely too high. The numbers on the right are the perfect squares. And you want to pick the highest one that will go into it without turning it into a fraction through division. But if you try to divide 48 by 36, you'll get a fraction. So we won't use 36 either. If you try to divide 48 by 25, it'll also be a fraction. But if you divide it by 16, 48 divided by 16, that's 3. So in other words, underneath the radical, you can rewrite 48. You can say 48 is the same thing as 16 times 3. And then you can split these up so the 16 has its own radical. And then you find from this that this is going to be plus or minus 4 times the square root of 3. So this is what b is. We'll need b to find the 2 points on the minor axis and also to graph it. But for now, let's go back to this step. I'll highlight it. Or even back here. At least for the equation, we only needed to find up to b squared. So now we can plug in everything. And instead of going further and graphing it, let's go ahead and start answering the parts on the left where we have the equation. So for the equation, we needed to know what hk, a squared, and b squared are. And we have that. If you see that h or k are both 0, or if you see that h and k are 0, both of them, then this part on the top, this would be the process. You'd be saying that this is 0 inside the parentheses. But because the center is 0, 0, you don't even have to do it this way. I'm just going to show the background steps. But if you know that the center is 0, 0, or that either h or k is 0, you can just simplify it like that from the beginning. You don't have to write the minus k or the minus h at that point. And then here, all we need to do is put the b squared here. This is where we have a 48 under x squared. And then for this one, this was the 64. And this is the equation. So far, do you have any questions about anything?
No, so far everything is pretty clear.
Okay, excellent. Now, let's see. We have the equation. The graph is actually the last thing because we'd be finding all these other things first. But we can go ahead and start crossing things off. Let's see. We found the equation, so I'll just cross that out. Or I'll just put a check mark next to it. We found the center, we found the vertices. We know what the foci are, but let's go ahead and just to show you the process. Right over here, we used the negative 4 to find 16. And we figured out through inference that, the other one would be positive 4. So whether you do it that way, or whether you come here and you just find the square root of 16, where you'd be finding plus or minus the square root of 16. you'd end up with plus or minus 4. So we'd have both of them this way. To find the foci, I'll just do that up here where there's some more space. So because this is an ellipse that goes up or down, primarily up down, and a squared was under the y term, then you just take the center and whatever you have for the y coordinate, you put c here with it. So if I was going to put it back with just the variables, it would look like this. You have h with k plus or minus c. And so that would be, because these are both 0, 0, you'd say that you have 0 plus or minus 4, which we just found to be c, right over here.
Okay.
And then that simplifies a little more. You can just say instead of 0 plus or minus 4, you can just say it's plus or minus 4. So these are the two foci. And so that takes care of this one. And I'll just write that here. We found both of them. You could always write it twice, like you could say you have the 0 and the positive 4 and the 0 and the negative 4. That's fine too. Now, after that, we have to find the 2 points on the minor axis. What you want to do is come back here and look at B. Whatever this number is, as a decimal, it'll be easier to graph that. So what you want to do is put the 4, or you want to find the decimal version of 4 times the square root of 3. Let's round it to one decimal place. That's approximately 6.9. So B here, it's the same thing as approximately plus or minus 6.9. This will make it a little bit easier to graph. I'm going to just redraw it real quick. So here, it takes about 7 units to get there. Let's say that that's approximately over here. This would be 6.9, comma 0. This would be one of the minor points. Let's say that this is about negative 6.9. So these would be the 2 minor points. This is enough to graph the ellipse. Roughly sketching it, the ellipse would look like this. And these 2 on the side, these are the minor points. The vertices are on the top and the bottom, and the foci are on the inside, where we have the 0, 4 and the 0, negative 4. So that's it. We did the 2 points on the minor axis, and in the process of labeling all of these, we also completed the graph.